So, hello everyone and welcome to our digital booth for the SPINpad technology. My name is Matthias Knoche and I am the responsible product application manager for the product group of speed sensors here at AB Electronic. As a product application manager, my main focus is to make sure that our products within the group of speed sensors are able to compete in the current market in terms of performance and cost. And additionally, I'm capturing the voice of the customer to ensure that we are able to adapt to future market needs. So, today I would like to give you a short introduction to our SPINpad technology, and since you are probably not familiar with the term SPINpad, you might be wondering what I'm talking about at all. Well, to keep things short in this introduction, try to imagine a sensor inside of an electric motor whose only task it is to determine the exact position of the rotor shaft within this motor. And this information is crucial to drive the electric motor with the highest possible efficiency and to enable a long range for the vehicle. So to put it into other words, the correct technical term for SPINpad is actually rotor position sensor. And with these kinds of sensors, it is possible to measure the exact position of a rotating element at high speeds of up to 100,000 RPM and convert this information into a signal format that can be evaluated by control units. So rotor position sensing has always been a very important market sector, but with the current rise of electric vehicles in the automotive industry, this type of technology becomes more important with each day, and the main focus switches from functional requirements to commercial points. Typical applications for SPINpad sensors are all high-performance electric motors, whether they are used in industrial or automotive applications. Electric motors are mainly used for traction purposes of the vehicle, but other fields of applications, including, for example, electric power steering or brake boosters, are also potential SPINpad applications. Compared to current market technologies, for example the VR resolver, the SPINpad sensors have a very thin form factor, high magnetic immunities, and have very many assembly options. Due to the fact that SPINpad sensors are equipped with active electronic components, it is possible to design redundant systems and meet functional safety requirements. I'm talking about the ISO 26262 here. And with the SPINpad sensor, the highest level of ASIL-D can be achieved. The main characteristics of SPINpad sensors are a very high accuracy of up to 0.5 degrees electrical. Of course, this number heavily depends on the sensor layout, the customer installation space and the application, but this number has been proven internally and validated internally. The maximum speed of up to 100,000 RPM, as I mentioned before, of course also depends heavily on the customer layout of the electric motor, so I'm talking about the number of pole pairs here. Concerning possible output formats, the analog signal is currently standard on the market, and the SPINpad technology is able to provide analog signals in either a single-ended or differential-ended manner. To be properly positioned for the future, our R&D Advanced Development Department is working closely with our customers in terms of digital output formats. Protocols like SPI, SEND or SPC are possible. So in order for you to understand the SPINpad technology a little bit more better and a little bit more in detail, we have prepared a short demonstrator for you. And right here you can see the sensor system with the sensor and the rotating target in the background. So the sensor is comprised of a sensor housing in the PCB. On the PCB we have the electronics area or the populated electronic components. And we also have the coil area, the coil structures which are incorporated into the PCB itself. So we have transmit and receive coils, which are being used to generate the signal. In the background you can see the rotating target, and so with this kind of sensor you're able to determine the exact position of this rotating element at a certain point of time. I would also like to show you some samples that have been designed and manufactured in-house, either in our prototype shop or on our series line, since we also have different products or different SPINpad sensors that are in series production. So as a first example, I would like to present the so-called resolver bearing. So our engineers have integrated a SPINpad sensor into a standard bearing, which yields a highly integrated smart bearing or resolver bearing. So this is this part, and you probably won't notice that this is a bearing at this point. If I turn it around, you can see it. So this is a standard bearing, which can be turned. And the outer housing has been extended a little bit to fit to house the target and the electronic components. And if I open it, you will see the PCB. This is the PCB with the included antenna structure, and on the other side the SMT components will be populated onto it. And inside this bearing you can see the target structure, and the target structure of course rotates with the bearing itself. So if I start to rotate the inner ring, you will see that the target is rotating as well. So if this kind of bearing is mounted onto the rotor shaft of any system, it is possible to sense the exact rotor position while also fulfilling the general task of being a bearing. And this of course offers great advantages concerning the installation space and the number of individual parts in an electric motor, since they can be reduced significantly. Well, and since rotor shafts are usually supported at 2 points, it is also possible to realize a torque measurement if 2 of those resolver bearings are used on one rotor shaft. Well, and of course all other features of the SPINpad technology apply for the smart bearing, such as the readiness for functional safety applications. Another possible sample part is this sensor. So the design might look familiar to you. This is the same design, or the same sensor design, that's being used on our demonstrator. And this is actually a part that will go into series production pretty soon. And this is a so-called directly overmolded part. So this whole sensor is housed in thermoset material. There's no cover on this, no seams, and therefore it is quite difficult for any fluid to enter this sensor. It is made out of one piece. And the antenna structure, or the PCB itself, is the same as for the demonstrator module that you have seen earlier. So this big aluminum piece that you see right here is the target that is being used also in the demonstrator module, and this is a target for 8-pole motor. So if we start counting the rectangular, well, let's say devices on the target itself, we will count 8 in sum. 2, 4, 6, and 8. So this is for an 8-pole motor or 8-pole electric engine. Another very interesting application or SPINpad sensor is this sensor that you can see right here. It has a very big Deutsch connector on it, as you can see right here. What is interesting about this sensor is the fact that it doesn't have any mechanical housing, so the sensor itself is being housed in the electric motor, which makes the sensor only being a populated PCB and therefore being quite cheap. And the price advantage of our current market technologies like the VR resolver is, well, quite significant, since this is only a populated PCB with a connector soldered onto it.